Welcome everybody to Dallas Personal Robotics Group for December 16th, 2025, Robot Builders Night Virtual. Tonight we'll do our usual presentations and then go around the table if anyone has any questions later on. Tonight will be the last meeting for December, last official meeting. Our Tuesday meetings are done with for the year. We will reconvene in January. Watch Discord and the DPRG list for dates, times. And our monthly meeting as well is, we're not going to have it on the 30th. And it's being replaced, I believe, by Robot Power Lunch at a date to be determined. So as well, I'm sure Paul and Doug will put something out and let you guys know if you want to attend the Robot Power Lunch. So let's get things going. Tonight we'll start it off with Ted.
Yeah, thanks. So I've been experimenting with my outdoor robot and the B&O 055 or 55. And anyway, I was trying to once again get the compass to give me some good results. I've tried it before and I usually end up giving up eventually and just going back to the gyros. But this time I put it up. So to explain, I had it working and I put it up on a mast about 2 feet off the robot and redid the wiring harness for the I2C. And now every time I pick it up to spin it to calibrate the compass, it resets. And I figured out it's because of static electricity. We get a lot of that in Colorado because it's so dry out here. So it has a reset pin on it, which I've always just left disconnected because I've never had a reason to reset it. But anyways, I figured maybe that was it. So I tied that to 3.3 volts, which is I think normally it's on a pull-up resistor, so that should help pull it up so it doesn't reset. But the darn thing still keeps resetting. So I was wondering if anyone had any ideas for how to isolate it from static electricity.
Yeah.
What kind of I2C driver are you using on a long cable?
I just have it on the Teensy. So I just have it plugged into the Teensy's I2C ports.
So is it actually resetting or is the I2C port hanging up?
No, it's acting like it's resetting. If I experiment around with it, did some resets, I wired up the cable so I could reset it through the microcontroller, and it acted exactly the same. So
how long the cable was?
The cable's about 2 feet long. It worked fine when it was 6 inches long.
Mm-hmm.
So the I2C spec is like 18 inches max.
Okay, yeah, maybe it's just barely too long.
Yeah. Well, what I used was like an Adafruit I2C buffer, which uses a TI chip to buffer it,
like
and
a range.
it gives really strong signals. Yeah.
That's
I could drive it 2 feet, 2 or 3 feet. Yeah.
Okay.
Yeah.
It's cheap. It's like $6 or something like that. Oh, I haven't checked the prices in ages, but it's not inexpensive.
Yeah. All right.
A repeater driver definitely help. You can also try playing with stronger pull-ups or put pull-ups on both ends of the line, depending on what you have now. And, since you have a longer cable, if you have a stable power supply at the device, you can put pull-ups there as well. But yeah, I mean, the buffer driver is a much better way to go.
Yeah.
Sure.
The other thing I thought about maybe was just putting a really cheap microcontroller in there and then sending it serial or something down the mast. But going halfway or something.
So
what kind of cable did you use, Ted and Mike? I mean, were they twisted pair, 2 strands of flat ribbon, bare loopy doopy wires?
Yeah, flat ribbon.
And Mike, is that what you used for your 2-foot run?
Yeah, right. On my other robot. Yeah.
So ground and signal right beside each other. Okay.
Does it only happen when you calibrate it?
Yeah, it's when I pick it up to calibrate it. As soon as I touch the thing, it goes zap. And if I'm really careful and ground myself first, then I can get away with it.
Wow. Okay.
Yeah, nurses in the hospital that I used to work at, especially in the OR, they would take, well, they had a person do it, but they would take copper wire and wrap it, into the sole of the shoe, because in ORs they use oxygen, and you don't want sparks or static, and that would ground them pretty much to the floor.
Yeah, maybe I can just take like one of those grounding straps and hang it on the ground and walk around,
there you go.
with it on the ground.
Drag a bare wire behind you or something.
Yeah.
A chain. Yeah.
Well,
I did that on a pair of slippers.
I've seen that done in electronics repair labs, where they'll take the base of the chair and they'll actually drop a chain down to the floor. Yeah. Of course, it has to be an ESD type floor. But yeah, because the plastic wheels, right, isolate the whole chair assembly. And that movement across the fabric, on just your human movement can create a lot of static. Yeah.
Yeah, human body model is like 2,000 volts or something, I think, isn't it?
If you can draw a spark, you're doing in sea level air, a spark is 20,000 volts per inch.
I think it's like 6,000 or 8,000 volts before you can even feel it.
Yeah. But Ted, I think when you grab your robot, you're not grabbing it by the wires, or you're just grabbing the metal chassis, right? In your
just the chassis.
Yeah, so it's like an EMF into the wires. Yeah.
Yeah.
I had a spark like that, cost me the first Raspberry Pi 4 I had with an SSD on it. I walked across the living room and went to turn it off, and that.
Well, I mean, just like belts right before the contest, right? I go to turn it on, and I think that was transient voltage, not really static, but yeah, that's not a good sound to hear when you turn something on.
Yeah.
Okay, so here's another approach for you, Ted. This one might seem a little wacky, but do you have some like solder wick, some good flat braided wire?
Sure. Yeah.
Do you? So how about if you make a bonding grounding strap and tie your chassis and run that in parallel with the ground and signal wire up to your I2C board. So in other words, give your I2C board a really solid ground.
Yeah.
And that way, when you put the perturbation into the chassis of the base, the path of least resistance will be your big, wide, thick, high frequency, low inductance braided wire.
I like it. Yeah. I will definitely try that.
I'd almost bet a decent beer that has a chance of working.
Yeah, even cool. I don't know if you've looked at them, but like the shopping carts at Walmart's, they all have a little lead that touches the floor around the wheel. And if you get one that doesn't have that on a nice dry winter's day, and it'll arc right across the your both hands on the handle, because the handles are typically plastic, and when you touch the metal part of the thing, it's like, whoa, it'll give you a heck of a shock. Yeah, I don't know if it would using like a bundle shielded wire with that, like you have whatever, the two I2C signals, VCC ground, and then a shield around that. Do you think that would do any good?
But those will add capacitance and such too, right? So you
Oh.
got to be careful with those. The thing is that because I had to deal a lot with EMC when I did laser rangefinders at Texas Instruments. So one of them was a 20,000 volt pulse forming network. So anyhow, you learn quickly there that high frequencies don't travel down the core of the wire. They travel through the electrons travel on the surface. So what you want is lots and lots of surface area, and that's why you want a super fine wire that's lots and lots of super fine braided wire, because it really gives a low impedance to high frequency zaps, like a broadband noise of a EMF of a static. Okay, that's
Yeah,
my
we had to wind certain inductors with Litz wire. I don't know if you ever heard of Litz wire. It's like many, many strands of very fine wire, and same sort of thing. You know, it's to try to reduce the skin effect.
Or leverage it.
Yeah.
Yeah, leverage it.
Yeah. Yeah. And if you, it was like night and day if you didn't use Litz wire, say use the equivalent number of turns on just a solid wire. Well, and it was to get the Q up to the quality. So you had a much higher inductance versus resistance in the coil. So, but
All right, got several ideas to try. That's awesome.
Yeah, let us know how it works out. I'm always
I
curious.
will do that. I think I'll try yours first, Carl. That sounds easy.
I go for easy.
Follow-ups are always great. Gives us something to go back on and review and see how it worked.
Yeah.
Okay, next up, Scott, are you ready?
I think so.
Okay, next up we got Scott.
So like I said in the preamble, this is a robot chassis from a commercial robot. It's actually one of the robots we saw if you were in the tour at the robot shop. This was actually the base of one of the robots that was there. So this one was destined for the dumpster, and I was able to acquire it. So basically, I took the battery from the robotic cell, the garage cell they were having. I bought the drives there too, and I just right now just have it hooked up to an RC remote. We got a controller board in there that's handling the PWM generation. But I was amazed at how smooth and quiet this thing is. I mean, you can barely hear it. The problem I'm having with it, though, is it's not really a dynamic control. So think about the way your car works, right? Where you have a gas and a brake pedal. So if you want to go, you hit the gas. And if you want to stop, you have to hit the brake pedal. Well, the way my PWM is set up right now, I really don't have that kind of functionality. So I've been kind of playing around with some different approaches because since I have two motors, I just have one micro. It's not a closed loop, right? I'm counting on the drives to say, okay, well, if I wanted to go so fast, it will go so fast. But the problem is this thing's heavy because you put the battery in it, and this is a big, heavy cast aluminum chassis, probably a good 30 pounds, 40 pounds with the motors too, because this whole hub is the motor. There is no linkage there's a stub that mount, it's like almost like a scooter motor or a razor motor, right?
Hoverboard, yeah.
Like a hoverboard motor, yeah. They're rated at like 250 watts, so they're decent torque, and they are torquey little things. I was playing around with the software and had added, I wanted to reverse directions. And instead of reversing directions when the speed was at 0, I cut and pasted to the wrong line, and I reversed directions when the speed was maximum. And the whole thing tumbled over and blew up the drive, and it was really pretty ugly. Because I just had one of these motors mounted to this kind of haphazard rig on my workbench so that I could make it work, and the thing's tumbling all around, and it was pretty violent. But So like I said, I've been able to get it working kind of. I'm still working on the dynamics so that you could like position control basically, right? Not just velocity control, but how do you place it at a given spot and not, run past it. I really don't know what the application for it's going to be because it's kind of big and bulky and heavy for any kind of robot contest. But it's been kind of fun to play with. I've got this video here. Let me share my screen and I'll show you the video. Everybody see that?
Yep.
Yep. All right, so I'm just driving this thing around. Just to give you a better look here. I'll stop it right there, and you can see I have a little. This is just a microcontroller board that I laid out and had laying around, not doing anything. So I kind of modified it, and you can see the two drives here. And like I said, they have the Hall effect sensor feedback, and right now I don't have, again, the encoders hooked up. And then I just have a little RC, receiver in here, and I have my microcontroller handling because it's like, what is it, SMB bus? So all of it's PPM, the pulse time modulated stream. So that's how I'm kind of controlling it. So here I am just kind of showing it. Now I'll drive it around a little bit. Give you a little bit better look here. And get a better look at the drives and the control board.
Where's the battery?
It's underneath. It's
okay.
between the wheels underneath the chassis.
Is it 12 volts or 24? Or?
It's 24.
Okay.
I used one of those 25 volt cells that the robot guys had, or the lawnmower robots had for sale, which are really nice batteries. They're the ion or iron phosphate ones, lithium iron, they're like the PO4 things. So, like I said,
Yeah.
I was brave and actually sat on it and drove it around, and I'm glad I didn't take any video because it was, it wasn't a smart thing to do. So,
That's a old guy in a hoverboard video, I think.
yeah, but well, you got to imagine, because I had a piece of plywood across the top, and I had my heels kind of hanging off of the edge, So I mean, I looked. It was pretty goofy, and it was super sketchy because I had the remote in my hand, and I'm trying to, drive myself around without putting myself on my face or my butt. So, yeah, it was challenging, but said it's just kind of fun to play with these wheels and try to figure out what the what I can do with them. So,
yeah, and others I use those same drives hooked up to a two hoverboard motors.
Yeah,
and they did have with the 3 Hall effects for the 3 different phases. You could get like a I guess kind of an encoder output. I think it was like 48 pulses, 96 edges.
I think you can. There's a circuit where you can kind of tap into it and get it. It's kind of, I think it's like a lot like a magnetic encoder that you see, where you get so many pulses per rep. Whatever it is, 6 pulses per revolution with 2 sensors. But with these, you don't have. There's no gear down, right? So a lot of times with those, right, the encoder is actually on the motor, and then you have a 50-to-1 gearbox or whatever, and so it's enough counts to really make a difference. Whereas here, it's all direct drive. So and the encoders in here are 1024, so it's 1024 pulses per revolution. But it's about I did the math. It's a little over 13-inch circumference. So that's a decent resolution as far as positioning goes. But my next step is to hook into the encoder so that I can actually get speed feedback. And then I can try to better control the motor and not just, go coast. Okay, now brake. It's more of an active, very dynamic, run, brake, run, brake, run, brake, so that you have absolute control over the motor, especially with the weight here. And I was talking to the friend of mine that works for them, and I was asking him, well, how do y'all handle the braking? And he said, yeah, that's one of the things they struggle with because of all the mass. So that's what I've been up to.
And plus,
Trying to figure out what to make with it.
Yeah, I'm tempted to put like an outrigger on the front of it so that I can like stretch my legs out and be, a little bit more stable on the platform. It still sounds like a trip to the ER, but it also sounds like fun. So I don't know.
Hoverboard actually does make a basically it's a seat with one wheel out in the front, and you can there's a bar where you can put your feet on the on the front of the thing, and
yeah,
you have two levers that push or pull the hoverboard platforms, and that's basically how you steer. So yeah, that probably work with that. You got same concept. So
You can put a big platform on it and put your trash cans on it, and it can take it to the curb and bring it back. Yeah.
There you go. Yeah, that would make my wife happy. I'd build a robot that actually does something useful.
Don't get carried away.
Yeah, I mean, I don't want to have to go there, This is all supposed to be for fun.
Well, thanks, Scott. That looks to be an interesting project if you can get the motor speeds under control.
Yeah, I mean, I think it'd be more fun for some sort of suicide buggy, but than a robot. But we'll see. But yeah, it's fun to play with the control of them, because it's something completely different than what you're used to with the, like a brushless DC with a full H bridge. So just a matter of prioritizing it and all the other projects I want to get to. So
Okay, next up we have Mike.
Yeah, so I've added a lot more information to my GitHub file, and I guess I could go to that later, but the important thing is showing it pushing boxes around. It's pretty much ready to get something that can fight back or something and see what happens. I don't have a lot of strategy involved right now. I'm not sure exactly how to do that and how to debug it unless I had something to fight against. But I'm gonna take my computer over to the arena. There it is, and my start switch is the front sensor, and so what I do is I hold it over the front sensor for a second, and now it's start doing the 5-second countdown.
is that a kit, Mike, or did you build that chassis?
Pardon?
Is that a kit you started with, or did you build that?
I built it from scratch.
Okay.
3D printed it.
Okay.
Yeah, so my Polulu box has some big Allen wrenches in it, and I put some rubber bands on it to give it some traction. So it's a relatively
Looks like it's doing pretty good.
yeah. So it's ready to go. I mean, and I have it. I added some code in it today so that if it gets off the mat, it'll stop. So when it measures more than 2 edge sensors, it goes back to idle, and then I can start it again. 1, 2, 3, 4, 5.
See, there's something useful. If you need boxes pushed out of the center of the room, you know.
Yeah.
Yeah.
Yeah. So,
Or go retrieve them from the front door when UPS drops them off.
Yeah.
yeah. Oh, that's a good idea. So
is that our second star for the night? Scott got I would say a black star for progress on his base.
Yeah.
And Mike gets a gold star for significant progress, autonomous mode.
yeah. Yeah. So this is my
RP2040.
this is my README file, and so basically I've gone through this. Let me get rid of this whole thing here. So this is the 3D file of it, and one thing I want to do is I've realized that it's not a good design. Like I designed it to have sensors in the back and in the front, but the back sensors are pretty useless. The edge sensors are. And I've noticed that a lot of the mini Sumo robots have their wheels all the way to the back. And that allows you to, if someone tries to lift you up, you still got traction. So I'm going to redesign it to get rid of the sensors in the back and push the wheels all the way back and open it up so that it can have so someone can go try to grab it and lift the front up. And using the IMU to detect the lift and then react to it by backing out and doing a big spin, trying to get out of the clutches of whoever's trying to do that. And this is my my battery is in this hole here, and it gives me a lot of weight. And one thing I did do, and I don't have the in here yet, is can you see on my regular window? I added a top here, and it's full of pennies to bring me to 1 pound, to 500 grams.
You lift it higher?
Pardon?
You lift it higher towards the camera?
Oh, okay.
Yeah.
Yeah. And so the front here, the top here has is full of pennies in there. I mean, I guess you can see some shiny pennies in there. But so I noticed that it gives it lots more traction, because it was like at 250 and now it's about 500, and now it can push the box around with lots of rubber bands on it. This is it with the top open, and with all the sensors are connected with these cables, and then these are the two motor drivers here, and so you can see here that the motors are mounted here. These are the motor clamps, and that's the back of the motors with their wires. And then these are the sensors here on the back. So I'm gonna get rid of all the sensors and just push the motors all the way to the back. And that'll give me some, it'll allow me to do extra stuff, like, well, it'll allow me to have it, like I said, be lifted up and then detect it and get out of the range. Right now, if they lift it up, it'll hit the bottom here, and the wheels will be off the ground. That's a really bad design. So,
But you may benefit too from, moving the pennies lower, right? Having a lower center of gravity.
yeah, my box is full. But if I move it back, I can add some more weight down lower. So I could, like right now, the battery's here and the battery compartment would go back, and then I could put pennies in front of the battery in the front here. So I don't want to redesign the circuit board. The circuit board goes all the way to the front with the sensor right here. And so I really can't change the shape without redoing the circuit board, and I just don't want to do that. I just want to 3D print a body, because the body is like in one piece, so everything fits in there except for these two 3D printed ones in the lid. So
Outsource your body to be printed in steel.
I could, but I'm not really super happy with this design. I think it's a really decent first shot, and my second shot moving the wheels back would be better. Now, if I had a really great design, it'd be okay. Now I'm going to immortalize it in steel.
Well, I would suggest putting the battery or the pennies under the board, because the board's not going to have a lot of weight. So you would be able to kind of lower your center of gravity. And if you brung the controller board up, right?
Yeah, I could mount it up higher.
Right.
Yeah, because right now I was thinking, oh, this is going to be pretty heavy, and then it only braid out at 250. So it's like, oh, well, I guess I should have added up all the weights, but yeah, I could somehow, raise the board up some more. But
Fill it up with epoxy.
that's not very heavy, but yeah. So this is the RP2040. So I'm using almost all the pins on it. I'm using one of the analog pins to measure the battery voltage. So if the battery voltage gets down too low, like 6.6 volts, which is 3.3 volts per cell, it'll just shut off all the regulators and the motor drivers and just be, dead in the water. So I'm trying to protect my battery, and it can run for hours because it's a 1.2 milliamp hour battery. And so I went in here and I added all my components, the regulators and the motor driver sensors and the circuit board. And then I added a little bit of information about my my movement and what my sensors do, and a little bit about the code. So I got more documentation README to do, but this is a really good starting point. So that's my show and tell from last week. I just showed it moving, and today it's actually moving with a purpose. So.
Well done.
Very nice.
Okay. Next up, we have Karim.
Right. So mine is just a simple request to the club to visit my my new website, check it out, see if it's useful for you. If any of you have, very selfishly, if any of you have public websites, if you find it useful and you would link to it, I would appreciate that. It hasn't even been, I don't think it's even been indexed by Google yet. So it's really hot off the presses, but it is, you've seen some of the documentation before. So it's all stuff that's generated from my Google Docs. So it's not like it's, let's see.
Can you put the URL in the chat?
Yeah, sure. I was going to show it real quick.
That would be good.
Why doesn't it want? Oh, there it is. You guys see that?
Yes.
Okay, so it's called Ponderics. And it's basically a set of articles and project documents. So the articles are like I've shared before in my Google Docs link, and so it's basically those. So they're more like internal notes. They're not. None of this is necessarily meant for, you know, tutorial, public consumption, people who are like newbies to robotics necessarily, that kind of stuff. But I have a lot of articles in here, and so if you go to the articles, you'll get the full listing. There's 21 posts showing right now. And if you go to projects, these are the things like they're either going to be related to buyer command or my Docker project for automating like DevOps for my Sentry Robot. So that's what those are. So they're just articles that sort of document it. These are things that are actually tied back to my repos. So if you click here, it'll take you back to GitHub. If you, this will just take you to my general GitHub, but it'll take you to the project repo, and it's got a search function up here, and you can change it to light mode if you want, all that kind of stuff for whatever's comfortable. So anyhow, that's all I wanted to say about that. There's like cool graph here, but it's not fully populated yet with everything. So this shows how all of the documents are related to each other. And if you click on them, you can get like access to all of the external links. You know, so you can just zoom in and play around with it. So that's basically it. So if anybody finds any problems with it, my quality assurance cycle isn't complete yet, but I think I have most of the stuff fixed. So that's it. That's all I wanted to share.
How do we get there again?
Ponderics.com.
Okay.
I will put that link in the. I don't think you can. I wonder if Google has it yet. I don't think so.
It did not, or Bing did not.
I tried Google, it did not either.
Yeah, I don't think it's indexed yet.
Have you set up the webmaster console and such?
It opened up. It's I've got it on Google.
The site is there if you type in the whole thing directly, right?
And that's what I did. Type it in robotics.com and up it comes.
Yeah.
I got it direct too. So yeah.
Nice.
Good. Something to look through tonight.
So if everybody does this, then maybe we'll start getting indexed.
Right. Yeah. I need to start the siphon going.
Well, but Karim, you can kickstart that. Have you set up the webmaster console at Google or Bing?
Mm-hmm. Yeah. I just haven't done it yet.
Oh, okay. So you know, okay. So you know how to do that.
Like I was deploying this latest version of it as this meeting started
minutes ago. Yeah.
Yeah.
I'm just saying because you can request it to crawl if you haven't seen that before.
Yeah, I've seen it.
Okay.
I actually see. So I'm actually deploying this through Cloudflare pages.
Oh, nice. Okay.
And I'm seeing requests, failed requests to index it there. So I'm not sure what's going on because I do have robots allowing the site. I do have. I've disabled it for AI crawling for training, but the regular Google and Bing crawlers are enabled, but they show as failing. So there might be some weird setting going on there as well. For some reason, most of my hits are coming from Singapore at the moment.
Yeah. Yeah, there's some weird offshore stuff.
Mm-hmm.
Oh, do you have sitemaps and such?
Hmm?
Have
A
you?
site map? Sure.
Yeah.
Yep.
So okay, so you got all the hygiene in place. Oh,
Yeah.
give it
Yeah. I
time.
think so. Yeah.
Okay, I can't remember you had a spy versus spy character in there. Was that
Yeah.
part of God, what was it? Warner Brothers, Looney Tunes cartoons. They
Mad
also had
Magazine.
Boris and
Mad Magazine was
Asha.
Spy versus Spy, and they did have an animated series, but I don't remember who produced that.
I thought it was actually in Mad Magazine was Spy
It
versus.
was Mad Magazine.
Yeah,
and
it was Mad
obviously
Magazine.
It was stills in that, right? It was just regular cartoons.
Yeah.
But,
If you search for them on YouTube, you can find the animated ones.
but there are some animated ones as well. Yeah.
Not that that dates anybody, but
Is it still showing? Am I still presenting?
Yeah, you're still presenting.
Oh, stop that. All right.
Thanks for that, Karim.
yeah, I always think of Boris and
Natasha.
Tasha as how to deal
Different,
with
yeah.
during the Cold War, how to deal with Russians and what Russians are really like, so but who knows? Maybe we weren't indoctrinated, but it certainly seems like it. So
Okay. Well, next we had Isaiah. As I said, the pre-meeting, Isaiah, welcome.
Yeah, thank you guys. I appreciate you letting me in here. I work with Sentry Robotics, and we just had our own little robot sale, and that's how we met Paul. And he sent me an email about this, and I thought it'd be fun to join. But right now we make lawnmowers right now, so if I can figure out how to share my screen here, I can show video.
So you're selling off all of those older models? Is that what it was?
Yeah, we pivoted to a new form factor, and we think it's gonna be successful with the landscapers. And we developed our software using a kind of RoboMo that we modified heavily. But yeah, that's the base. Is a RoboMo.
You use an RTK?
Yes, sir. Yeah. All right, I had to give Chrome permission here, so I don't know if it'll let me do this. I might have to leave real quick if that's okay and join back.
So is that what Paul had referenced? Is that where everybody's buying the platforms from?
Yeah.
I
Okay.
believe so, yeah.
And I believe Paul had some platforms stashed at his neighbor's house, and he's been selling them off. I think they're going on eBay now. But I know that a few members have bought some from the sale.
Yeah, I think Doug bought one.
Can you guys see that okay?
Yes.
Mm-hmm.
All right, so these are the new mowers that we're running on. We're trying to do some landscapers to run these guys. And so I do the mostly software, but I helped a lot with the low level stuff because I've got a hardware background with escape design. But just thought I'd show you this as like an intro.
So 100% electric, or is it gas engine driven?
It's 100% electric. Yeah.
Okay.
We actually bought these first push mowers from Lowe's and then converted them to autonomous using the same kind of software and hardware from our first smaller platform that we did with the RoboMo. Yeah, let me see if I can change.
I had a question. It was going right around that steel plate. it seemed to be hunting. Do you do you know what was happening there?
Yeah, we have this, we've got different speed modes, and I think when it, what's happening here is these are still pretty prototype, and so we haven't fully tweaked the speeds. But when it goes down to too low of speed, it takes a lot for the mower to, it's because they're so heavy, and these decks are aluminum. I don't know if you can see my mouse or not, but the deck right here is aluminum, and so these are pretty heavy mowers. And but anyway, it takes a lot of energy for the robot to turn, and then as soon as it starts turning, it turns too much, and then it starts going back and forth chasing that heading. And the higher speeds, it's not as much a problem because it's more consistent. It's just trying to go straight.
Okay.
I only have a look at the bunch straight, but actually, we can look at the ones in the background. They might be doing better because they're not having to.
So are those custom drive wheels, or did you get that off the shelf somewhere?
These are tiller wheels, and we're using 24-volt wheelchair motors.
Oh, okay.
Yeah.
And those are the wheels that come with the wheelchair motors?
No, we had to put those together. Yeah, we've got a friend of ours that machines an adapter for us to attach to the motor.
Oh, okay.
Do y'all map these areas, or is this just on the fly obstacle avoidance, or what?
Yeah, we map the areas out right now, and part of what I'm working on is the on the fly obstacle avoidance.
But like for a baseball field, does it make the really cool diamond shapes in the grass?
Oh,
Are you
Little hatch patterns, yeah.
Yes.
Yeah, we do have control over that. So we have got a couple different settings, but as soon as we started actually showing these to people, we kind of we hid a lot of those settings because we wanted it to work consistently.
Yeah,
but,
yeah.
Yeah. Sorry, I'm trying to find another video here.
Looking for field testers with tall grass.
Yeah.
Yeah, I'm in the yard size, but we do want to test more. Can I turn this off?
Dramatically reduced cost unit for testing? No.
I've got snow under about a foot of, some grass under about a foot of snow.
Put a snowblower on it. Yeah.
Yeah, exactly.
I did that.
This is
Snow blow the backyard.
I got over an acre of grass you can mow if you want.
Yeah, that would be good. We're in Irving, and we do a lot of mowing all around DFW though for our testing.
Oh.
This is an example of it catching the object and then doing a real-time avoidance where we didn't map that out.
Yeah.
Is that a 2D LiDAR or is that a 3D LiDAR?
We don't use LiDAR actually. Well, I don't know what you would classify it as. We use a depth camera to determine the actual distance, but it's not like its own LiDAR.
Okay, it looked like something rotating it there.
Yeah, it's just a safety thing we added, so people know if it's on, is a really big bright, like don't come near it. And whenever the robot stops, that light turns off. But I on my own time, I was working on my own robot that does not look nearly as cool. And let me see if I can change that here. I play a lot of disc golf or frisbee golf, and we always have a wagon that we pull that has our cooler and our bags and our discs. And so I thought it'd be cool to have one that automatically followed me. And
did you see?
But right now it's me using the keyboard to control this, so it's not automatic. Very, very early stage.
You could do blob recognition with a cheap camera, like an ESP32 camera, and have the blob be a certain size so that it stops or goes, depending on how close or far away it is from you. That's a real easy way to do it.
Yeah, that's a good idea. My first thought was just using I have a webcam that I was practicing on, and this is just using a Raspberry Pi, I should say. My motion light always goes off. This is just using a Raspberry Pi, but and it's not quite fast enough for me to do person detection running like a YOLO model, because that was my plan, was if it can detect a person and give me a bounding box, then it knows exactly that it's a person, and if it's to the left of the screen, we should move to the right to keep them centered. And if the bounding box area is too big, then we can stop. And if it gets too small, then to speed up. So that was the plan, and I haven't gotten to the implementing that yet. When I tested it out on the Pi, it was only able to read a person about once a second, and I think that would be too slow for it to catch on. I have it here, but this is the one I couldn't get running. Let me stop sharing my screen. This is it right here.
Yeah, I like the furniture casters, the dollies.
Yeah. Well, this was because when I first built it, the plan was to attach it to my wagon, and then when I turned it on, it kind of looked like a hoverboard, and the whole electronics started spinning. The wheels didn't spin, so I need to put something on the front to keep it from spinning itself. It's a pretty simple setup. I just have a cobalt tool here, like a drill. I don't know if you guys can see. There we go. And then this is the motor driver. I was trying to get the 24 volts into 5 volts here, and I think that's why my Pi is not starting up now. I just have a little buck converter, but that's probably where my issue is. It was working, as you saw in the video, but now it seems to not want to power on. These are the same wheel-tone motors that we use for the mowers, and they're only like $100 for a 2-pack. So some of them come with the wheels, like these are wheelchair wheels.
Are they like 12-inch diameter?
I haven't actually measured them. It says it's got something on the side here.
Yeah, it's a good size. Well, 12 inches a good size for outdoors for
10 by 3. I don't know if that's the wheel, but
Looks to like 8
I have a question about what's the use of a cooler in playing disc golf? How about that's just frisbees?
yeah, I'm not allowed to answer that in my work shirt.
Frisbees have to be maintained to a certain temperature.
Yeah, well, they fly further if they're cold, right?
Right, yeah, exactly.
stiffens them up. Yeah. Right.
So I did have a question. So the commercial mower you were demonstrating,
Yeah,
was that running autonomously?
yes, sir.
Okay. And then this one was running on a remote.
Correct. Yeah, I was using my keyboard for my personal project here.
Okay.
Yeah, the mowers, the commercial mowers, we use RTK as the main driving thing. We don't right now. We don't have any kind of LiDAR or anything like that, other than the depth camera, like I said. But we're trying to keep it simple, and we're moving towards more visual navigation based on that depth data. But right now, it's mostly RTK.
Which depth camera are you using?
The RealSense 435.
Okay. That's one of Intel's, right?
Yeah.
Not anymore. Intel divested it,
No.
and the former employees spun it off into a new company. So it is continuing to be supported. I'm using a D455.
Oh, cool.
They're good cameras.
So
Yeah,
what's the suggested retail price of the of your newer motors or mowers rather? Do you know?
Well, we're really going for the commercial landscapers first, but it could be. I'm not really in charge of that part, but I think it could be anywhere between 10 to 20,000. Yeah, I mean the mowers themselves, like I said, they sell those push mowers already at Lowe's, and they really are like the best of the electric push mowers in my opinion. So that's why we wanted to convert those to start.
Yeah, it seems like maybe it's the Lowe's and McKinney doesn't carry a lot of electric mowers. At least I haven't seen. Well, I saw an EasyGo inside, but that was, well, it was electric, but it wasn't, autonomous. It was actually set up like a zero turn,
Yeah. Yeah, no, I don't think that, well, I mean, we're hoping that we're the first to the market with the autonomous push mower. Like, it's a dual mode, so you can actually just control it manually if you want to. That's the benefit for landscapers, is that if the robot does something crazy, then they can still take over. Or if there's hard to reach spots, they can still take over. And it's kind of like cruise control for your car.
Mm-hmm.
So
But yeah, none of the ones in Lowe's are autonomous. That's what we're doing right now.
Mm-hmm.
how's the battery swap out? Do you swap the battery out or have to charge it in the unit?
No, it's a hot swap.
Okay.
And we have an internal swap battery just to keep the main electronics up. That way you don't have to get another RTK fix just from changing the battery. But that's just a little 5-volt guy.
So what kind of RTK? Do you have to have a local base station or
We use a RTK service, so it's, I think we're at like $40 a month for that per robot, and which is kind of factors into the cost. And it's nice though, because then you can go anywhere, and it's like a 5-minute map and then you can start mowing autonomously.
That's showing some promise. It's looking good, and it's like you say, with the ability to mow in manual mode as well. You've got the bases covered. That basically, you know, the human can do the perimeter, the tougher stuff, and the robot can do the wide open areas.
Yeah, exactly.
And if it's like up here, getting somebody to mow the lawn or getting somebody to snowblow a driveway is almost impossible. It's the guy I used to use when I work out of town, when I'm gone for the week or something, used to cut the grass. Well, he still cuts the grass, but he can't get people to work in the winter to slow driveways. So he had to shut that service down. It's sad that can't get workers.
Yeah, that's the problem.
Maybe that's the next step. Go from Mobot to Snowbot.
There you go.
You know, with this disc golf bot, we were thinking of making a blow bot where it's follow somebody who's doing like weed whacking, and it just blows all the trimmings back into the yard.
Nice.
Seems like you could use drones for some of that to sort of blow the snow out of the way. And yeah.
You went a whole different direction than I was thinking with your blowbot.
Yeah.
Uh-oh.
While keeping it PG.
Yeah, the whole point of the robot is to follow humans, so I was thinking of naming it the Stalker.
Well, that's good. Basically, I gave you a gold star for your commercial robot platform, and I gave you a black star for your home robot chassis.
Thank you.
That's all you get, though, is just the stars.
Yeah.
It's not like you're gonna get some gift prize in the mail.
For what it's worth, you got to mention.
There you go. Yeah, you'll be in the summary of the meeting as getting 2 stars.
Good. I appreciate it.
If I remember, because I didn't remember to do it in the last meeting. Well, thanks. So that was it for the list of presenters. I guess we can open it up. Any questions, comments, ideas, websites?
No John K today for additional websites.
John has 1 or 2 Instructables websites.
I was going to ask Tom Crawford if he got his 5Xs running, his time of flight.
No, please forgive me. There's too many other things going on here. I have to get out of the way. I just thought I'd share. I'd forgotten there was a box from Amazon out on my porch tonight, so I had to get some new batteries. So there's the batteries, and there's 5 coin cells in there. That's the Amazon box that came in. has to be big enough to put all the warnings on it, I think.
Yeah, yeah.
5 coin cells.
Usually coin cells I pick up at the dollar store.
The dollar store doesn't have these ones. They're for my Subaru clicker. So I guess they're not that common.
I just got from China little radar, millimeter wave radar. So put some motion sensors out in the yard. So I had some PIR ones, and the problem with the PIR sensors is they don't work at all below 0 degrees.
Ooh, of course.
32F, they shut off. They basically will not work. And they work fine in the summer, and they won't work in the winter. And these are rated down to -40. So we'll give them a try with a little ESP32 and see if we can detect motion outside.
See if that gets you into the early winter.
Yeah, well, we'll see how it goes. So it's I haven't been doing much with robots. I've been still rebuilding my home network.
I've been trying to get rid of all of the surplus computers I've collected over the years. So some of the bits and pieces that are real junk will get recycled. Some of the stuff I've been taking pictures of and posting. So I posted a couple of motherboards that used to work really well, but have sat around here for way too long. A Pentium 1 and a Pentium 2. I thought, well, $5 each, because I don't want people to just throw them in the garbage. So I posted them on Marketplace. An hour after I posted them, I had gotten 4 inquiries. The next morning, I had 14 more inquiries. I had no idea that really, really old motherboards were of so much interest.
You could have put $10 on it.
I could have put $100 on it, apparently. Needless to say, they're gone.
I ran into that with the old ISA cards on the old motherboards. So I had an optimizer at work, and it needed an ISA bus. And try to find an ISA bus in the last 20 years on a computer. And I remember basically, I think it was home. I went home, grabbed an old motherboard I had, brought it to work, and I rebuilt the PC to get an optimizer up and running.
What was it running? DOS or?
It was running. It was a version of not Windows. It was a version of BSD. So like Linux, BSD though, Unix system.
Okay.
Okay, I found a link just to cover John since he's not here. I found a link that might be interesting. It surfaced a while ago, but it's a walking chair. It does stairs.
Oh, wow.
Why don't you show the video, Carl?
Okay, let's see if my computer can keep up with it. And Pat, I wanted to ask you about field of view on those sensors you mentioned too, but where's the video first here?
I'll look that up while you're doing that.
Okay. I have to change my power plan. My computer does not like screen scraping all this stuff. Just a moment. Okay, we'll give this a shot. Here we go.
I was gonna say, hopefully it does better than the Russian robot debut. I don't know if you guys saw that or not. It's like
It's Toyota. They usually do pretty good.
Is that coming across all right?
Yeah.
Yeah.
Somewhere or other they show it getting into cars and then up the stairs.
Wonder if it has prank mode where you sit down, go to sit down, and it backs up.
Yeah. That'd be evil, wouldn't it?
Yeah.
Come on.
Or the auto sit where it sneaks up behind you and pushes you into its seat, right?
Yeah.
There you go.
Oh, anyhow, so there it is, getting you into a vehicle. Of course, it's a low vehicle, but it also does stairs apparently.
Wow. Pretty strong.
Yeah. Yeah, talk about emergency room. No concern about it falling over there, right?
Yeah. Yeah, it does look like it has a high center of gravity.
Yeah.
Wow.
So anyhow, I thought that was fun.
Mhm.
Hey, so Pat, can I ask you about those? You mentioned PIR, and then you've got the millimeter wave radar ones.
Yep.
Are they both just like single cone, or like what's their radiation pattern?
I'm not sure about the PIR. I got them out of a box of old alarm system stuff from my dad.
Uh-huh. Okay.
The millimeter wave radar I bought on AliExpress, and I posted a link, and I couldn't get the field of view from the site, but when I look up the part number, the LD2420,
Yeah.
24 gigahertz, field of view tells me it's approximately plus or minus 60 degrees.
All right.
I don't know if it's kind of like a main lobe and side lobes, maybe.
Yeah, so it doesn't give much of it. There's a couple advertisements for it, Walmart, Open eLab, but nothing specifically that I see.
It
Plus,
seems
plus
like
or minus 60 degrees.
but it's optimized for motion detection of humans, or?
It's for motion detection of humans. So there is other models. Some of them will detect standing still or very slow moving. So there's different modes, and it's a serial signal you can get coming out of it, so that it gives you a string of information, quite a bit of information on what it's detecting. You know, what range and, you know, what's happening and that sort of thing.
Okay.
So it's possible to create an exclusion zone by, you know, if you're looking at the string to say, okay, it's too far out, so ignore the people on the sidewalk.
Okay.
So
that's pretty cool. So a robber could still rob your house. He just has to move extremely slowly.
Yeah. But it's got a range of up to 6 meters. So 3/4 of a meter to 6 meters.
Yeah, that's pretty good.
Okay, that's
So
pretty big.
Yeah. So I'm just looking to try to trigger backlights, trigger camera, you know, make sure a camera's recording when that happens. That sort of thing.
That's cool, but it doesn't work for the thing I'm thinking of. So I still have as my mental exercise the concept of an orange can that's capable of evasive maneuvers. Yes. So what kind of I'm thinking maybe the micro mouse or the nano mouse is the platform for inside so it can turn and move around. Yeah. But then what kind of sensors can we put around it? Like 4 or 5 sensors so that it can detect a robot coming at it and back away from it. That's what I want to figure out.
Yeah, I noticed that those simple, cheap IR sensors wouldn't detect my black body.
Right. Yeah. Yeah.
But the time of flight sensors detected it. Okay.
They're a pretty narrow cone.
You could fit this guy almost inside a can.
There you go.
Out around the can.
I was thinking
Maybe
about
you
that.
get a pretty good view.
Paint the top of it orange, maybe.
And it's not going to be top heavy at all with that up high. No way.
Well, I put it into the bottom of a can, and then just cut, you know, like 4 spots.
anyhow, it's a design target.
Well, I borrowed the styrofoam mini Sumo ring from DPRG, and it had some nicks and scratches, and so I bought some flat black paint and used a little foam brush to get the paint smoothed around, and so so I got rid of all the scratches and stuff, because my robot would see a scratch and then thinks it's at the edge or something. I probably need to put some filtering, like it has to see it for a couple of times, but then when I'm running real fast and get close to the edge, you really want to respond really fast. So I'm not sure how in competition how well they keep the surface black without having nicks and scratches and stuff that it would see as a edge sensor. But this was really nice because I could touch it up pretty fast, and it's really flat. It's actually flatter than the paint that was on there. So
yeah, I would bet you're the first one to do any repair work on that disc. So probably since it was made,
but I got the styrofoam one because it's really light. Because Mark made a wood one, but it's pretty heavy. So I saw Mark on earlier. He took off. Oh, okay.
Yep, looks like it.
Your PIR comments, Pat, were interesting. I use PIRs to trigger recording on my yard cameras outside. Very simple setup. They're actually photocell-based PIR sensing lights. So I simply set the threshold on my camera system to pick up the light, and the light's PIR picks up whatever else is moving around. I was just watching a couple of hours ago. They picked up a fox going through my backyard.
Oh,
that's about -5 right now. So they're still working at that temperature anyway.
I would notice that they would cut off at, like, seriously, they were outside in my driveway at 0 degrees C.
That's amazing. I'm gonna have to keep an eye on mine. I never noticed that before.
So, and okay, well, these things are going to be useless. They work great in the summer. I was triggering recording, and everything was going good, and along come winter, and they just crap right out.
Yeah, these PIRs, these systems are cheap. They're $10 a pop, and they just work. But I admit I haven't paid that much attention to them in the middle of winter.
I suppose they could have something to do with the age or the exact design of it.
Well, when I looked up a lot of the specifications on PIRs are 0 degrees C.
Okay, good point, Pat.
So that's why I've been looking for an alternate, and so I found a bunch of boxes. And what else do we got? We've got an antenna, the radars, and some 80 or ESP32 8266s. And I'm just going to set them up with ESP Home on my Home Assistant, and have them just monitor and trigger all sorts of stuff. So, like, turn the lights on, flash the lights when you detect something, trigger the recording, stuff like that.
Yeah, the PIR sensors on one of the security lights is so old. It's kind of, I don't know if it's a Fresnel lens that's in front of the sensor, but it's like a multi-pattern lens that's kind of curved it's just a piece of plastic that's bent into the housing of the thing, and it's I don't know when it disintegrated, but it's not there anymore. And some of the plastic is like, just kind of flitting around in the wind, and it's like, okay, it's dead. So,
can't you 3D print something new?
probably could, yeah. So they're pretty cheap though. And
I do have a question. ESP82 or ESP32 C6. I've been trying to get these guys working on platform IO.
Oh.
So basically putting them in, trying to set up the platform IO programming environment for them. So grabbing the dev kit, C6 dev kit, C, and trying to program it. And I'm not having any luck at all. Almost all of the ESP32s I've been trying with platform IO are giving me trouble. And there's so many different variations on memory size, on PSRAM size, on everything in them to try to get it working properly.
So having any trouble compiling or loading?
Well, loading. So it'll compile and it gets everything ready and it loads it. And then all that happens is it goes through a boot loop and does a dump and, you know, gives out all the stack pointers and the registers and reboots and again and again and again. I've had all sorts of troubles. I finally got one working, and it's not the one I want, but I'm looking for one with PSRAM, so I haven't been able to get one going with PSRAM yet. So, and out of all the dumb things, it's just for an internet radio. So I've got a Raspberry Pi playing just music in the garage, and it works. And I said, well, why do I need a Raspberry Pi just to play an internet stream of music? When, you know, an ESP32 or has an I2S bus and can play the stream. But it's the problem I'm having is I'm getting some dropouts because I don't have enough of a buffer. I've only got 6,000 bytes as a buffer. And so if I could get a bigger buffer, I think it would help with some of the dropouts.
Yeah.
But I never expected to see that much problem programming an ESP32.
Are you programming it in circuit or just the bare board?
Both. Tried both. So
okay.
I don't have an amplifier hooked to it. So right now I have just an ESP32, and it's running. And it, like I say, it only has about 6K of memory that it's using, essentially internal memory as a buffer. And it's not, it's doing okay, but not something that I'd say, okay, I could put it out there and let it play. So that's why I was trying. I bought a couple different models of ESP32 C6s, C6 and a little S3 Mini, and both of them have given me. It's just incredible how much trouble I've had programming these things.
Yeah, I got the. I want to say it's a C3 Mini, and I've been able to program it okay with Arduino, you know, the IDE. So.
C3 specifically is excluded because I believe it does not have I2S.
Oh, yeah, probably not.
The S2 I think is excluded, and a C3 I think was excluded because it does not have I2S capabilities.
Okay.
So
Yeah,
just,
it was a C3, one of these.
I was wondering if anyone else was programming these with platform IO and having any luck with them.
Yeah. Nope, not me.
That's all I've got. So do we wrap it up, guys, or do we call it a night?
Might see you all next year, I guess.
Yeah, so that will be it. Keep an eye out on the lists and the DPRG list server and the Discord and website. And I'm sure, I know Paul was talking about doing a power lunch. So
yeah, Paul sent out a notice today saying that he was planning on doing it on January 3rd. But hadn't picked a place yet.
Okay. So
that came out on the DPRG list today.
So then our meetings are done until the new year.
Right.
So we will be meeting on the 6th.
All right. Well,
Okay.
Merry Christmas. Happy New Year. See ya.
Yep.
Take care, buddy.
Okay.
Christmas.
Happy Christmas. Happy New
Guys.
Year.
Good night.